Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 3 of the lesson on arithmetic sequences, and in this video I'll be looking at how to find the first term and the common difference if you know two terms in the sequence. So here we go. The third term of an arithmetic sequence is 12, and the seventh term is 28. Find the first term and the common difference. So let's just have a quick recap about the language and the variables that we use in arithmetic sequences. The first term is A, and then each time we progress one term along the sequence we add another difference, and that difference is common, which is what makes the sequence arithmetic. So the second term would be A plus D. The third term you'd add another difference, so we'd have A plus 2D, etc, etc. And that goes all the way up to the last term, which is A plus n minus 1D. And what we worked out in the previous videos is that whatever number term you're on, there will always have been one less difference. And you need to be really swift at just knowing that and writing that down very quickly. So if, for example, I say to you, what's the 10th term? You would say A plus 9D. If I said, what's the 18th term? You would say A plus 7D. So let's apply that to this one. We've been given that the third term of an arithmetic sequence is 12. So third term, one less difference. Straight away we're saying that is A plus 2D. Which you could also see there, first, second, third term. And we're told that that is 12. We're also told that the seventh term of the sequence is 28, so let's think, seventh term, one less difference, A plus 6D. So A plus 6D equals 28, because that is the seventh term of the sequence. Seventh term is 28. And what we have here is two simultaneous equations which we can solve to find the value of A and the value of D. So if I call this equation 1 and this equation 2, what I'm actually going to do to keep positive values here, I'm going to do equation 2 take away equation 1. So A take A is nothing, we've eliminated A. 6D take 2D is 4D. And 28 take 12 is 16. Now let's just pause for a minute and think about what this means in the context of the problem. 4D equals 16. Well, let's just think, how many terms are there between the third and the seventh term? Well, there's 4. 4 more terms, which means you'd have 4 more differences. So 4 more differences is the difference in the numbers in that sequence. So we've gone from 12 to 28 in 4 differences. They must be the same. So we have 4D equals 16. And now we can solve to say that D equals 4. So the common difference is 4. Substituting into either of those equations, so if I use the first one, A plus 2 lots of 4 is 12. 2 lots of 4 would be 8. So A would be 4. So the first term would be 4, and the common difference is also 4. And what we can do with this sequence is we can check that that is correct. If we start on 4 and go up in 4s, 8, 12, the third term is 12, it's looking good. 16, 20, 24, and as expected, the seventh term is 28. I wouldn't recommend doing that for larger differences in terms, but as it was just the third and the seventh, it's just a quick check to work out that we've got it correct. So you're given two terms in the sequence, we form a pair of simultaneous equations, solve them to find A and D, job done.